So exercise 13.5 in that question number 6. Here derive the formula for curved surface area and the total surface area of the frustum. Okay, curved surface area, that is this portion of the cone. So derive the formula for the curved surface area and the total surface area of the frustum of a cone given to you in section 13.5. Okay, using the symbols as explained. So here we have to derive the general formula. Okay, so he has given that a cone of OAB. Okay, and the frustum of a cone is nothing but here OA, that is OAB. Here OAB is a full, this is a cone. So the frustum of a cone means CD, that is AB, CD. Okay, this we have to derive the formula for curved surface area, that is curved surface area and okay, total surface area. So what is the difference between curved surface area and total surface area? So the curved surface area is nothing but the surface area belongs to this curved portion only. So total surface area means this is equal to curved surface area plus top area and plus bottom area. Okay, there are two circular portions are there. So this top area plus this bottom area. Okay, like this. Okay, so here this is difference between curved surface area and this total surface area. So now first we will calculate curved surface area. Okay, so the curved surface area means, you see here in the diagram there are two cones are there, that is cone OAB, this is a bigger cone, see here OAB, and one more cone is there, that is cone OCD. Okay, this is cone. So now here the curved surface area, this frustum of a cone, so frustum is equal to, so here the CSA of cone OAB, okay, curved surface area of this full cone minus the curved surface area of this smaller cone, that is OCD, curved surface of a cone OCD. Okay, so this you understood. See, curved surface area of the frustum means this is ABCD frustum, so that is equal to curved surface area of this full cone. Okay, this total curved surface area including this one also minus the curved surface area of this cone OCD, because we know that the curved surface area formula we know for the cone we know. So that is equal to pi into R into L. Okay, pi RL. So here cone OAB means, see OAB means R is radius. So here radius is R1. Pi into R1, pi into R1 into L, that is slant height. So here this is L1. Okay, L1 he has given. So minus curved surface area of the cone of OCD. So this OCD here, this is pi into here R2 here, this is R2, and this one slant height, this is what L2. Okay, so this is a CSF frustum. So pi R1 into L1 minus pi R2 into L2. In a triangle, we will consider in a triangle OPB and OQD. Okay, OPB, this OPB and OQD. So this portion we have considered only this one. So here this is O, P, B and OQD. Okay, so in this triangle, so what we can write? See here, considering these two triangle, we have to make a similarity. See here, this angle, that is angle BOP, that is angle BOP, this is equal to what? This angle DOQ. Okay, because this is common angle. So now OPB is equal to OQD. This angle is equal to, see, OPB, this is 90 degree, and here OQD, this is also 90 degree. Why they are 90 degree? They are perpendicular drawn, that is both are 90 degree as height are perpendicular, as height are perpendicular, like this we can write. So in that is AA similarity, that is angle similarity criteria, both triangles are similar. Both triangles, whatever we have considered, are similar. Okay, these are similar. So hence what we can write, if they are similar, see this PB is parallel to QD. So now the ratio, how to write this PB, this divided by QD, that is PB by QD, this can be written as OB by OD. So this we have seen in the triangle. Okay. That is corresponding sides of similar triangles are proportional. That is corresponding, because here corresponding sides means the corresponding sides of PB is QD. The corresponding side of OB, that is bigger cone, that is OB, that is OB divided by OD. So this is proportional. Okay. So now we have to put here putting, okay, here putting L1 is equal to L plus L2. Okay. See here L1 is equal to what? This L1, total L1 is equal to this L, that is L of this frustum divided by L2. L means frustum slant height. Here L means slant height of frustum. Okay. And here L1 means slant height of bigger cone. Okay. So L2 means slant height of smaller cone. Okay. So now here putting here PB by, that is R1 by R2, that is PB by QD is nothing but this is R1, so this is R2. So here R1 by R2 is equal to what? So L1 by L2. Okay. So L1 means total L1 means slant height of the bigger cone. So divided by this is L2 means smaller cone. Okay. So now here, now putting L1 is equal to L plus L2. Here R1 by R2 is equal to, so instead of L1 we have to write L plus L2. L plus L2 divided by L2. Okay. By R2 is equal to L by L2 plus L2 by L2. So this cancel. R1 by R2 is equal to 1 plus L by L2. Okay. L2 is equal to, so we have to calculate this LCM. So here this will be L by L2 is equal to 1 minus R1 by R2. Okay. So L2 is equal to, okay, L divided by 1 minus R1 by R2. So like this, L divided by, so here R2 minus R1 divided by R2. So now L into R2 divided by R2 minus R1. This is L2. Okay. So this is L2. So now from 1 what we have done, that is we know that here we have already derived that pi R1 L1 minus pi R2 L2. So we will consider this one. So make it as equation 1 now. Okay. So consider equation 1. So here I will write consider equation 1. So that is curved surface area of frustum is equal to what? Pi R1 L1 minus pi R2 L2. Okay. So here we will substitute this value of L2 here. Okay. So now here putting L1 is equal to L plus L2. So that what we have done here. So here L1 in place of L1, that is pi R1 into L plus L2. Okay. Minus pi R2 L2. L2 is equal to here this value, that is L into R2 divided by R2 minus R1. Okay. This value we will put here. So now here this is L2. So pi into R1 here L plus here L into R2 divided by R2 minus R1. Okay. Minus pi into R2 into L into R2 divided by R2 minus R1. Okay. So like this. So this is equal to LCM we will take, that is R2 minus R1. So here L R2 minus L R1 plus L R2. Okay. So minus pi into R2 pi R2 L R2 divided by R2 minus R1. Okay. This is same. So now here this can be written as, this is R2 minus R1 is common here. So this is after solving this one, pi into R1, this pi R1, okay, L into R1 divided by R1 minus R2. Okay. So minus pi R2 L into R2 divided by R1 minus R2. Okay. So like this it will come. So pi into L here R1 square minus R1 minus R2. Okay. Minus pi into L here, this is R2 square, that is R1 minus R2. So this is simplification here. Okay. So now here afterwards pi into L, So R1 square minus R2 square. So here both we have taken here divided by R1 minus R2. Okay. So like this. So now here pi into L, here R1 square minus R2 square means that is A plus B, A square minus B square. That is R1 plus R2 into R1 minus R2. Okay. Divided by R1 minus R2. So this gets cancelled. So here pi into L into R1 plus R2 is remaining. So this is curved surface area, frustum of a cone. So now what we have to calculate second portion, that is total surface area. So the total surface area. So here this is frustum of a cone means, so like this. Okay. So the total surface area means, so this only we have calculated here. So this plus this, that is top portion and bottom portion also we have to add. So this is equal to curved surface area of frustum plus the circular area of top one, which is having a radius R1, that is R1. So plus circular area of bottom. Okay. So that is R2. So now here this we know, that is pi into L into R1 plus R2 we will substitute here. So this is pi R square, that is circular area is pi R square, that is pi R1 square. So here pi R2 square. So this is the total surface area. So in this way we can calculate. Okay, we will go for next one. So exercise 13.5, in that question number 7. Derive the formula for the volume of the frustum of a cone given to you in the section 13.5 using the symbols as explained. So here the symbols are same here, and this is a frustum of a cone. So we know only, that is we know that the volume of a cone, that we know, that is volume of cone. The formula for this one will be equal to, that is 1 by 3 pi r square h. Volume of cone is equal to 1 by 3 pi r square h. So this we know. Okay. So by the use of this formula, we have to calculate the frustum, that is the volume of this frustum of a cone. So the volume of frustum of a cone can be written as, that is the volume of frustum of cone is equal to the volume of cone, that is OAB. Okay. Minus the volume of cone, that is OQD, because in this total volume, this volume has been removed. So the remaining will be the volume of this frustum. Okay. So the volume of frustum of a cone is equal to volume of cone OAB and minus the volume of cone OQD, that is bigger cone minus smaller cone. So now here this can be written as, here that is 1 by 3. We know that the volume of a cone is equal to 1 by 3 pi r square h. So here pi r means this OAB. For bigger cone, the r means R1, that is R1 square H1. Here the height. So the total height, that is P to O. The P to O is equal to H1. So here this is P to A, it is equal to H1. So minus 1 by 3 volume of a smaller cone, that is 1 by 3 pi into, here a smaller cone, that is radius will be R2. So R2 square, here this height will be H2. This is H2. Okay. So this is the volume of a frustum of a cone. So now we will consider triangle, that is OPB and OQD, same thing what we have done in the last exercise. So that is here angle BOP, same thing. Here angle BOP is equal to angle DOQ, because this is a common angle. This is common angle. Okay. So both are same. So now here same thing, OPB angle is equal to here OQD. Because why they are same? Because both are 90 degree. As they are the heights which are perpendicular. Hence AA similarity, that is angle similarity criteria, both triangles are similar. So now if they are similar means, you see here, this is corresponding ratios. The corresponding sides of similar triangles are proportional. So here this is a triangle what we have discussed here. This is O, here P and B, and here OQ and D. So here this angle we have equated here, and this angle also equated. So now they are similar. So now corresponding sides, that is I can write as PB divided by QD. Here this side, corresponding side is this one. So that is equal to this OB bigger cone, that is OB divided by smaller cone, this corresponding angle. Both are similar, and also equal to OP divided by OQ. So now we will consider this one, PB by QD is nothing but R1 by R2. So here this is slant heights. So now we will consider this one and this one. So OP by OQ. OP by OQ. OP means what? H1. Here total height divided by H2. That is smaller cone height. So now here after this, so R1 by R2 equal to H1 by H2. Now put H1 is equal to H plus H2. Okay. H1 is equal to H plus H2. Because you see, this H1 is nothing but what? This total height. That is equal to this H. H is the frustum height. So putting H1 is equal to H plus H2. Okay. So R1 by R2 is equal to now H plus H2 divided by H2. So R1 by R2 is equal to H by H2 plus H2 divided by H2. Okay, this is equal. So H2 cancel. So here H by H2 is equal to R1 by R2, okay, minus 1. This is plus 1 comes to here. Here LCM will take. So H by H2, H is equal to, here LCM R1 minus R2. So H by H2 is equal to, so R1 minus R2 divided by R2. So this is LCM 1. So now here after this, here H is equal to H2 into R1 minus R2 divided by R2. Okay. Or otherwise H2 we can calculate. That is equal to, H2 is equal to H divided by, this is R1 minus R2. Okay. Divided by R2 means into R2. So this is H2 is equal to now H into R2 divided by R1 minus R2. Okay. So this is H2 value. So after this, here you see, this is equation 1, we will call this. Okay. Now from equation 1, so here from equation 1, that is volume of frustum of cone is equal to volume of bigger cone, that is bigger cone, minus volume of smaller cone. Okay. So that is equal to what? 1 by 3, that is 1 by 3 pi r square h. Okay. So 1 by 3 pi r square h. So here 1 by 3 pi r1 square h1 plus minus 1 by 3 pi r2 square h2. Okay. H1 is equal to h plus h2. Okay. Here h1 is equal to h plus h2. 1 by 3 pi into r1 square, that is in place of h1, this is h plus h2, minus 1 by 3 pi into r2 square, that is h2. Okay. Now put this value, putting h2 value. H2 is equal to what? H into r2 divided by r1 minus r2. So now here after that, so this is 1 by 3 pi into r1 square, here h plus h into r2 divided by r1 minus r2, minus 1 by 3 pi r2 square, this is h2 is nothing but h into r2 divided by r1 minus r2. Okay. So after simplification, this will comes 1 by 3 pi h into r1 cube minus r2 cube. Okay. Divided by r1 minus r2. Okay. So like this it will come. So after that 1 by 3 pi h, here this can be written, that is a cube minus b cube formula, that is r1 minus r2 into r1 square plus r2 square plus r1 into r2. Okay, divided by r1 minus r2. So this gets cancelled. So here the value will be, this is equal to 1 by 3 pi h into r1 square plus r2 square plus r1 into r2. Okay. So this is volume of frustum. Okay. This is the volume of a frustum. Okay.
Thank you.